Today, I'm here to talk about the leading-edge protections for fan blades applied in aggressive environments such as, for example, underground mining and tunnel excavation environments. Well, but what is a leading edge? Similar to airplanes, the leading edge is the front part of the blade, which encounters the airflow, meaning the front part of the blade, and the trailing edge is where the airflow leaves the aerodynamic profile at the back, where it is sleeker. To produce the airflow in the fan, it is necessary that the fan blades create a relative motion with the air. This relative motion often has a high speed. Along with some abrasive materials, this high speed in abrasive materials can cause erosion of the blades. To reduce these harmful effects of erosion on the fan, it is necessary to install leading-edge protections on the blades. These leading-edge protections are important not only to increase the lifespan of the fans but also to ensure that the aerodynamic shape remains throughout the operation. This will also ensure that the aerodynamic performance of the fan remains throughout the operation. For this leading-edge protection to be effective, it is necessary for us to understand the mechanisms by which this erosion occurs. Several factors come into this equation, such as the type of material, hardness, mass of the particulate quantity, relative flow speed, protective materials, among others. It's also important to note that all these elements contribute in different ways to wear. For example, if I have an element like dust from hard rock and another element like water, each one has a type of contribution to wear. If I measure this wear for a certain material in the laboratory, I have one result for dust and another result for water. Now, if I put these two elements together working for erosion, the result will not be the sum of the laboratory results obtained. It will be a much greater erosion because there is an interaction between the wear mechanisms of each of the elements. This makes determining erosion quite difficult. All of this is to say that it is very important for us to understand the environment where the fans will operate and everything involved in the erosion of fan blades. For example, if there are hard rocks, the size of particulates, if there is water or no water, the speeds involved, etc., so that we can determine the best types of protection for that particular operation. Well, this is quite an extensive topic, which this introductory video only begins to explore. And if you want to learn more about this and more about our fans, you can follow our blog, where we bring articles and more details about it.